Okay, so this is 1D for ion electron method. So you have your equation here. You're going to start by getting oxidation numbers. So these singular elements are going to just have the oxidation number that's there. So Ce has 4 plus, I has minus 1, Ce has 3 plus, and for this one here, oxygen is always minus 2, so you're going to have, you're just trying to figure out what iodine is. So blank plus -2, and there's 3 of them, equals, your charge up here is negative, so you're going to have -1. So to get that, you need +5, right? Yes. So your charge on iodine is going to be +5. So now that you have oxidation numbers, you are going to think of your saying oil rig. So oxidation is losing, reduction is gaining. But remember that it is opposite. So even though it says oxidation is losing means the charge is going to go up. So you have to think of that when you're trying to figure it out. So our first one, we'll start with oxidation just to make it easy and go through the process. So you're looking for one that is going up in number. So smaller on the left, larger on the right. So that would be iodine, since it has a charge of -1 and then it goes to a charge of +5. So I'm going to switch colors again. Oxidation. I just put that on the side, but you don't have to. It's okay if you don't know which one it is. I don't think you get marks for it, so you just write what you have on each side. So you have iodine, the charge of -1 goes to IO3, the negative charge. So first of all, we're going to leave the valence electrons till later, just because that comes into play when we're balancing stuff. So to start, you are going to try and balance this out. So we have oxygen on this side and oxygen on no other side. So we're going to have to add oxygen to the left. To do that, you add H2O. So plus H2O. There's 3 here, so we need to get 3 there. So there's going to be 3 H2O. And then now we have to balance the H's that just popped up. So that means we're going to go back to the right side, and you're going to add, there's 2 times 3, there's 6. So you're going to add 6H. That's positive. Now since this is a basic solution, you are going to have to balance those 6 H's out with OH's. If this were an acidic solution, it would just be what you have right here. You'd just keep on going with that. But since it's basic, you then have to add the OH's. So you're going to add, since there's 6 H's, you're going to have to add 6 OH to each side. So this side has 6 OH, and the other side, I'll fix this in a sec, plus 6 OH. Now what you're going to do, since anytime you have a basic solution and you're going to end up with H's and OH's, you're going to turn this into H2O. So I'm just going to write this on another line. So we have 6OH plus 3H2O plus I minus, which goes to IO3 minus, plus 6H2O. Now that we have that, you can see that there's H2Os on both sides. There's the 3 and there's the 6. So you're going to cancel out the 3, all 3 here, and this one's going to just switch to 2H2O. So your final thing for the oxidation is 6OH negative plus I to the 1, negative 1 times iO3 plus 2H2O. Just checking that that's right. Yes. No, sorry. This is not 3. This is not 2. This is 3. Because we just subtracted. Just gonna go back. It's 3H2O. Because we took out 3, and then this side we also took out 3, so this is actually 3, not 2. That's the oxidation side. I'm gonna scroll down. If this thing will let me. And we are going to, oh shoot. Okay. Okay, I'm just gonna go up top then. So now we're gonna do the reduction one. So we already did our I's, so we're going to do our CEs now. CE4 plus went to CE3 plus. This one's pretty easy. There's nothing else to balance. Now is when the electrons come in. So for down here, for down here, our our electrons, it went from -1 to +5. Just gonna write this out again. -1, +5, you can see it up top there. So the change was actually 6 valence electrons. Nope. Sorry, nope, I'm looking at the wrong thing. Yeah, it is. Okay, yeah, 6. So you had 6E. That's not in the equation. I just like to write it separate so you can see it. And back up here, there was only a change of 1. So to balance it out, we need to get each of both the oxidation and the reduction to have the same amount of valence electrons. So since 6 is the bigger one and we can get this 1 up to a 6, we are just going to multiply by 6. So you already have, this is a reduction. So the electron is going to be on the left. So we're just going to multiply all of this by 6. So then you have 6E minus plus 6. Oops, that's a nasty 6. 6CE, which went to 6CE3 plus. And then you're just going to add from both sides. So I'm going to do that somewhere. This is our original. I'm just going to cover it, I think. Maybe I'll highlight it. That was the original. But now I'm going to just add from both sides. So, sorry, give me one sec. And down here, since this was oxidation, we have our 6. We have our 6E on the right. So when I write the equations, I just cancel out the 6E's. I don't even write them in because there's going to be one on each side. So they are just going to instantly cancel out. So just going to start adding from both sides. So on this side, I just already know this is going to be canceled. So we have 6CE4 plus, that's all from that side, so you go down 6OH plus 6OH plus plus I, which goes to 6Ce plus IO3 plus 3H2O and then our electrons just cancel, and that's your final product. There's nothing else to cancel out. Just looking through here to double check that that's right. So that's your final answer. Right there.